Okay, a quick video to talk again, to give other examples about the one-to-one property. It's really just, here you see there's an equal sign. My equal sign means once I have the same, if I bring my two sides with only one base and that base turns out to be the same, then it makes it so much easier because the only thing I have to do is solve for my exponents. So in order to be successful using this method, you have to have some sort of basic knowledge of your powers. What do I mean by powers? Something like 5 to the power of 4, right? So these are things like this, like 625, 3 to the power of 4, 81. So these are little basic things, right, that makes you successful in doing those type of problems, because then you start recognizing those numbers. It's like, wait a minute, 125. I know it's the number 125 and 125 here. I know I cannot, it's a fact, 25 is not a power, 125 is not a power of 25, but maybe it is a 5. If 5 to the power of 4 is 625, maybe 5 to the power of 3 would work. So you just have to start trying numbers. Because I know 5 times 5, right, is 25. And 25 times 5 is 125. Bingo. We got our base. So now what we're going to be doing is we're going to recopy our numerator there as 5 to the power of 3 and leave a parentheses because we're going to combine our exponents. Now let's deal with the base after. Let's rewrite the right hand side, 5 power of 3 to the power of 2k. Now I'm not done. I do have a 1/5 there kind of in the way, so I do have to take care of it. So careful. 1/5, I need to change that into a number, right? And like a regular, I know base 5 is okay because that's what we want. We want just base 5s here. But we need to find a way to change, to bring the 5 up. And in order to do that, just remember, you put your exponent negative. Usually I ask you to get rid of the negatives, but sometimes you need them. If you need a negative, just put it back. Okay, for the sake of this problem, you need to actually have a negative at the top. So we're going to have 5 to the power of negative 1. Then next step, I'm going to put that, that in a little smaller. Okay, so now let's take care of those exponents here. So 5 to the power of 9k over 5 to the negative 1 equals 5 to the power of 6k, right? Now you have two choices here. You can use the quotient rule, or you could also bring that 5 at the top, right? And combine the other way. But let's use our quotient rule. What's the quotient rule again? If I have x to the power of a over x to the power of b, I do x to the power of a minus b, right? Therefore, I have 5 to the power of 9k minus negative 1. Careful, minus negative 1, because I'm subtracting a negative number. So I get 5 to the power of 9k plus 1 equals 6k. Look at this wonderful thing that's happening here. I have a 5 here and a 5. An expression, if there's an equal sign here, this means those two expressions have to be equal. My 5s are already equal. The only thing I'm missing to be equal now are my exponents. So let's solve our exponents so they are equal. Let's combine our like terms. Let's say negative 9k, I got, sorry, I don't have enough room. I'm gonna, bring this whole thing here, sorry, okay. Then I have 1 equals negative 3k, so k equals negative 1/3. And this is the value of my exponent, my value of k. Now what I'd like you to do is try that number here, that next number by yourself. Pause and come back and do it again, and then look at my answers, okay? Okay, so we have 81 here. Again, 81, 243, and 9. We need to find a common base. Okay? So this could be 9 to the power of 2 if you wanted to, because I already have a 9 here. But the problem is that 243 is not the power of 9. So let's dig a little further. If it's not 9, then can we go back down to 3, make it smaller? So 3 to the power of 4 is 81, right? And think about it this way. If 9 times 9 is 81, can we say 3 times 3 times 3 times 3 equals 81? Same thing. Okay? Think about those things. Make those relationships. Because otherwise you won't be able to continue here. Like, you'll be stuck, completely stuck. So now I know that 3 to the power of 4 is 81, right? So there, try to do 81 times 3. So 1 times 3 is 3. 3 times 8 is 24. Look, bingo, we have it. Try it. Meaning another 3. So it's 3 to the power of 5 to the power of 2x minus 1 equals, and now let's change our 9. This is an easy one. 3 to the power of 2 to the power of 2. Okay, so now let's combine our exponents using the power rule of exponents. So we get 3 to the power of 12x times 3 to the power of 10x minus 5 equals 3 to the power of 4. Good? Then, let's combine using a product rule. So we remember the bases are the same, so I'm allowed to add the exponent. So it's 12x plus 10x minus 5. So 22x minus 5. So 22x minus 5 equals 3 to the power of 4. Again, boom, we have our two bases that are the same, guys. You're not allowed, you see here you have 2 and here you have 1. You're not there yet. It needs to be one base on each side. So, ciao. Then I'm going to put my 22x minus 5 equals 4. Let's add 5 plus 5. 22x equals 9. 22. X equals 9 over 22. There you go. I hope this helps a little bit.